Okay, Math 2, we're going to do 42 to 48, and I'm looking at this right now, and I'm going to tell you this is going to be a long video, because judging by the questions here, you're going to be in for a while. So, if I have to pause, I'm probably going to pick up after 15 minutes on another video, so just a heads up. First one, make a complete graph of the function f of x equals absolute value of x minus 3 minus 1, and label all of its special points. So, basically, you want to actually graph, hopefully, that came into your consciousness. And we know it's at positive 3 and negative 1, so it's going to be somewhere down here. That's your vertex. And then your vertex, the value in front of the x, the absolute value is, well, technically it's a 1, but it's positive. So our graph is going to be a upward. There you go. And we're finished. That was 42. Okay, 43. Okay, examine the graph at the right that shows 3 parabolas. Okay, so we have a parabola in green. I'm going to do the parent graph in green because this is the one for f of x equals x squared. And then, okay, so this is the x squared one. Sorry, that's a blob. And then, what is the domain of f of x? So, we did this, when we did this last year, it was, we did something called a vertical line test a little bit, but, I'm trying to find a piece of, there it is, to show you what I'm talking about, because it actually helps. So the domain basically means the x values. And what you have to imagine is that there's kind of a line that is hitting the x-axis in general. It's coming out here from infinity, but technically this thing just kind of keeps on going up no matter which way it's going. So if it's coming out from, if there's this line coming here, technically out in infinity, it's still touching the green parabola, right? So as I move around this way, it's still touching the green parabola, it's still touching the green parabola, and then I'm going to keep on going, but it's technically still touching the green parabola, but it's just really high up there. You can't see it because we're a little limited on our range, but it's still touching the green parabola. So everywhere you go, it's always going to touch, all the values of x are still represented. So the domain of f of x, in this case the parent graph of x, of your parabolic function, is always going to be all real numbers, because all the numbers of the x values are represented. Okay, but in this case the range is not, because if we go the other direction, I'm touching the green graph, I'm touching the green graph. When I go up into the boonies, I'm still touching the green graph, but as I come down, it actually starts at 0. So on the y-axis, with y being at the origin of 0, that's where it actually begins, at y being at the 0, and all the values at 0 are represented, and they're all bigger than 0. So technically y is going to be greater than or equal to 0. These are the 2 main ones for your function of f of x. Okay, write possible equations for the 2 other parabolas. Okay, so let's look at the dotted, well, I'm going to call this the dotted red one. Okay, let's see, you have, it's going down, right? So we have h of x equals negative, and it is, its vertex is at 6 and 3, so I know it's going to be at x minus 6 and up 3, so plus 3, it's going to be squared. And then it's a little wider than the original green one. I don't know how much wider, so I'm just going to guess. Maybe it'd be like, I don't know, a third. I don't know, I'm just going to guess. All I know it's fraction is because it's wider or compressed vertically than the parent one. All right? And then it says, do the same thing for the narrow one up here. So the blue one up here Also has a vertex at 6, 3, but is upward facing. So now we have g of x equals, and it's kind of skinny, so, or stretched vertically. So I'm going to say, I don't know, maybe it's a 3, for all that I know. And it's going to be at x minus 6 also, and then plus 3. Because the vertex is at positive 6, right? And then positive 3 up. Okay, so that was 43. And then what's the domain and the range for g of x? The domain is all real numbers again, because we're in the same issue as with the green one. All real numbers. And the range, although for the one in blue, the range actually picks up at 3 and then it goes up. So all the values of y that are greater than or equal to positive 3, because it's going to go up. The range is represented by the y-axis. All right, that was 43. 44. What are the x-intercepts and the y-intercepts and the vertex of x squared minus 2x minus 48? Sketch the graph and write the equation in graphing form. So before you even do that, you're supposed to actually put it in graphing form. So I'm going to go over that one more time with you because it's technically completing the square. That's what you're doing. You're going to complete the square for x squared minus 2x minus 48. So we have an x squared, we have minus 1x, we have minus 1x because that's half of this one. So this is technically x minus 1, x minus 1. So the number in here should be negative 1 times negative 1 is just 1. Yay! So what number can we add to both sides? Because we have negative 48 and we want to get a positive 1. So technically we're going to be adding 49 and 49 to both sides. So this is going to end up being so like plus 49, plus 49. So this is going to be equal to 49 on this side. So we have x minus 1 squared equals 49. And then I'm going to move that over. So x squared minus 1. Oh my goodness, I can't believe it. X minus 1 squared minus 49. Okay. This is the graphing form of your function, or just look at your learning log. And then find the x-intercepts and the y-intercepts like you should know how to do. And your vertex from your graphing form is now at positive 1 and negative 49. There you go. All right, that was 44. 45. This is a very strange question, but I guess we can go with it. Eliana likes to use an app to graph her runs. Okay, so she's got a Fitbit hanging around. The graph at the right shows her run from the house to the park. Write a description for Liana's run based on the graph. So this thing says she ran 2 miles to the park. All right, I get that. Rested for 10 minutes. All right, because she didn't move at all, so she was just chilling for 10 minutes. And then she ran home more quickly. All right, that works for me. What was Eliana's running speed from her house to the park, and then give the units. Your hint is speed is equal to distance traveled over time. So running speed from her house to the park. From her house was at the beginning to the park is, well, when she got to the park, that was the end of the park. So distance traveled was 2 miles, and the time it took her was 20 minutes. So technically, her speed was miles per minute, right? So her speed was 1 over 10, 1 mile, in 10 minutes, or better known as 1 over 10, which is, I don't know, what's 1 over 10? What's that? It's not 0.1. Why am I thinking this is a weird number? My head is 0.1. Duh. Okay, so 0.10 miles per minute. Okay, so this is her unit rate. 1 mile in 10 minutes, or better known as 0.1 miles per minute. This is her unit rate right there. What was Eliana's running speed 25 minutes after she started her run? How does your answer relate to the slope of the graph? 25 minutes after she started her run, she was resting. I don't know what this thing needs. I'm assuming that you want to go from here to there. So technically, they want us to do it again, except she still traveled 2 miles. She hasn't really gone anywhere in 25 minutes. So this is now a 1 mile over 12.5 minutes. Better known as, now that I definitely can't do in my head. 1 over... So this is technically a 0.08 mile, 0.08 of a mile per minute. Because in 2 miles, since at 25 minutes she's still at 2 miles, she hasn't really covered any distance in that last 5 minutes, so technically you take the whole thing. Okay, what was Eliana's running speed from the park to her house? Justify your answer using a graph. Okay, from the park, I guess it was over here. She left the park and then she got to her house. So this was at 30 and this was at, I'm going to say 48. Was it halfway? Is that 48-ish? Is it halfway between 45 and 50? I don't know, maybe. What's halfway between 45 and 50? Something 7.5, I'm sure. 47.5. Okay. So let's say 47.5. It looks like it's about halfway. Alright, so in between 30 and 47.5. So 47.5 minus 30. Sorry, 47.5 minus 30 is going to give you 17.5, right? And then she ran from 2 to 4. So technically 4 minus 2 is going to give you a 2. So she ran 17.5. No, she ran 2 miles in 17.5 minutes. Sorry. So she ran 2 miles in 17.5 minutes. So she ran 2 miles in 17.5 minutes. And then that gives you 1 mile in 8.75 minutes. So technically she ran 1 divided by 0.75. Oh yeah, okay, so she ran around 0.11 mile of a mile per minute. Okay, and that was her unit rate. Okay, that was 45. 46-ish. What time am I at on this thing? Okay, 13 minutes. Alright, we'll just hang in there. Oh, man. Okay, I'm going to pause, and I'm going to do another video starting with number 46.